For decades, the automotive industry has treated six-cylinder engines as a luxury reserved for performance cars. Large SUVs and premium sedans, powerful and smooth, but often thirsty. In today's era of downsized turbo for cylinders and rapid electrification, the idea of a fuel-efficient six-cylinder can sound almost contradictory. Yet Mazda has never followed the industry playbook blindly. With the official unveiling of Skyactiv-Z, Mazda's leadership is signaling that internal combustion engines still have untapped potential. This new powertrain isn't about chasing headline horsepower or brute force torque. Instead, it represents Mazda's most advanced effort to blend six-cylinder smoothness with real-world efficiency and lower emissions, without sacrificing driving enjoyment. According to Mazda executives, Skyactiv-Z is designed to bridge the gap between traditional gasoline engines and full electrification. The goal is a smarter, cleaner, more refined powertrain for the next decade. This isn't nostalgia engineering, it's strategic engineering grounded in research, real-world data, and Mazda's long-standing philosophy of improving efficiency through better combustion rather than simply adding bigger batteries. So why is Mazda still investing in six cylinders when many automakers are walking away? Mazda engineers argue that engine downsizing has reached practical limits. While turbocharged four cylinders can produce impressive peak figures, they often face challenges with refinement, durability under sustained load, and real-world fuel economies, especially in larger vehicles. As one senior powertrain engineer explained, smaller engines frequently work harder in daily driving. That means higher thermal stress, more boost pressure, and less consistent efficiency outside laboratory test cycles. A well-designed six-cylinder, by contrast, can operate under lower stress while delivering smoother power across a wider range of conditions. Skyactiv-Z is Mazda's answer to what it sees as the industry's one-size-fits-all approach. Rather than endlessly shrinking engines, Mazda chose to optimize combustion itself. Positioned above Skyactiv-G and Skyactiv-X, Skyactiv-Z represents Mazda's next-generation gasoline architecture. While Skyactiv-G emphasized high compression and Skyactiv-X introduced compression ignition concepts, Skyactiv-Z is a broader rethinking of combustion efficiency at scale. The new engine is expected to be a naturally aspirated or lightly assisted inline six, paired with advanced hybrid technology, rather than heavy turbocharging. Mazda's stated goals include dramatically improved thermal efficiency, lower real-world fuel consumption, reduced emissions without sacrificing performance, enhanced durability, and seamless integration with electrification systems. The company also says the engine is being developed to meet upcoming global emissions standards in Europe, Japan, and North America. Perhaps the biggest surprise is Skyactiv-Z's promise of fuel economy comparable to smaller engines. Mazda is pursuing this through several key innovations. First is ultra-efficient combustion control. Building on its expertise in precision combustion, Mazda is using advanced sensors, extremely fast engine control units, and refined airflow management to maintain optimal combustion timing in nearly all conditions. Unlike many turbo engines that enrich fuel mixtures under load, Skyactiv-Z aims to run lean more consistently during everyday driving. Second is lower RPM operation. One advantage of an inline six is its ability to generate strong usable torque at lower engine speeds. Skyactiv-Z takes full advantage of this by reducing the need for higher PM operation, which cuts fuel consumption during cruising, highway driving, and moderate acceleration. In real-world conditions, engine speed and load often matter more than cylinder count. Third is reduced mechanical loss. Mazda engineers have focused heavily on minimizing internal friction through lightweight materials, optimized bearing surfaces, and improved oil flow. Even small reductions in friction can translate into meaningful fuel savings over a vehicle's lifetime. Industry analysts note that Mazda's strategy aligns with recent real-world fuel economy findings. In some everyday driving scenarios, a lightly loaded six-cylinder operating efficiently can outperform a heavily stressed turbo four-cylinder, something laboratory tests don't always capture. This helps explain why some premium brands that aggressively downsized are now quietly returning to larger engines paired with mild hybrid systems. Mazda has strongly hinted that Skyactiv-Z will use an inline six layout rather than a V6, and that decision is significant. Inline six engines are naturally balanced, requiring fewer counterweights and balanced shafts. The result is reduced vibration, lower mechanical complexity, improved longevity, and better long-term efficiency. In short, Mazda aims to deliver luxury-grade refinement without luxury-grade fuel consumption. Electrification will still play an important supporting role, Skyactiv-Z is expected to work alongside mild or full hybrid systems that provide electric assistance at low speeds. Regenerative braking, seamless engine shutoff during coasting, and torque fill during acceleration. The key difference is that Mazda is using electrification strategically, not as a bandage for inefficient combustion. Reliability remains central to the program. Unlike e-Boost, turbo engines that often operate near thermal limits, Skyactiv-Z is being engineered for lower stress and longer service life. As durability experts often note, engines that don't have to work as hard tend to last longer, a simple mechanical reality that matters greatly for long-term owners in markets where charging infrastructure is still limited. While Mazda hasn't confirmed every application, Skyactiv-Z is widely expected to power next-generation SUVs, premium side ends, and large crossovers, likely on rear-wheel drive platforms. The engine will play a key role in Mazda's push toward the near-premium segment, competing against rivals that rely heavily on turbocharged force in an industry increasingly split between full electrification and aggressive downsizing. Skyactiv-Z represents Mazda SE middle path 1, focused on balance, efficiency, and real-world usability. As Mazda's CEO has emphasized, the company's goal is not to abandon internal combustion prematurely, but to perfect it while preparing for the future. The environmental argument goes beyond fuel economy alone. Mazda points out that large battery production carries a significant carbon footprint by extending the life and efficiency of advanced gasoline engines. The company believes it can help reduce total life cycle emissions, particularly in regions where electricity still depends heavily on fossil fuels. Ultimately, Skyactiv-Z signals confidence in its engineering identity rather than chasing every industry trend. The company continues refining what it does best: engines that are engaging to drive and sensible in the real world. For enthusiasts, Skyactiv-Z suggests that smooth, naturally balanced engines aren't disappearing just yet. For everyday drivers, it promises lower fuel costs without sacrificing refinement. And for regulators, it offers cleaner combustion without massive infrastructure demands. Skyactiv-Z isn't a step backward from electrification. It's a bridge, a carefully engineered solution that acknowledges today's realities while preparing for tomorrow's demands. If Mazda delivers on its promises, this could become one of the most important gasoline engines of the decade, not because it's the biggest or the fastest, but because it may be the smartest,